All right. So I have number 17. 4 square root of 2x plus 7 minus square root of x plus 15 equals -1. So if you have a radical equation, meaning you have one or two different radical terms, the first step is to isolate one of the radicals. Doesn't matter which one, just get one of them by itself. So I'm going to opt to take this term to this side since it'll be positive on the right side, and isolate square root of 2x plus 7. That'll be one less negative sign I got to deal with. So on this side, it'll be positive square root of x plus 15, and then -1. Right, once you have radical isolated, look at what root it is. It's a square root. So that's going to dictate which power you're going to raise both sides to. Since it's a square root, I'm going to square that. So the goal is to get rid of the radicals. But then I have to also square this side. So this will be the easy side. Square root, you get the radicand. That is what's underneath the radical. And that would be 2x plus 7. Now, this is a difference of two terms. This is times itself. So that means it is the square root of x plus 15 minus 1 times that quantity again. Now you can write that all out and FOIL it. But anytime you FOIL a sum or difference of two terms squared, it's going to multiply out the same way every time without exception or fail. So we can skip a couple steps. That first term, so what you're going to have is you got this, then minus this. It'll multiply out to be the first term squared, which in this case is square root of x plus 15. So it's just going to be x plus 15. That's the first term squared. Now the middle term will always be this times that. Just multiply the two terms together. The sign will be whatever the sign was here. In this case, it's subtraction, so it's going to be minus. That times that doubled. The reason is the outer and inner products, if you would FOIL it out, are always identical, and they're that times that. So this, at the end of the day, will be 2 times the square root of x plus 15, or x plus 15. And then plus the last term squared, and it's 1, so it's just plus 1. Are we okay with multiplying this out?
Yeah.
Okay. So once you've multiplied it out, then collect like terms, and if you still have a radical term left, which we do, isolate it. So I've got x, I'll move it over, so that would leave me a net of x on the left side. I got 15 plus 1, that's 16. Taking that over, that's going to be 7 minus 16. That's going to be -9. And then I'm left with -2 times the square root of x plus 15. So I'm going to repeat. Once I've got this isolated, I'm going to square that side, and I'm going to square this side. So doing the same thing I just did here, it's a little simpler. First term squared would be x squared. Product of the two is 9x, doubled is 18x, so minus 18x. And then plus 9 squared, which would be 81. On this side, it is two things multiplied together. So it's -2 times this. By exponent rules, we can square both factors and then multiply those results together. So squaring -2 would be 4. And then since it's a quantity in the radicand, make sure you put parentheses there because that 4 is going to have to be distributed. So you would have 4 times the quantity x plus 15. So where radicals are gone and all the problems that you will face, you'll never have to raise powers more than twice. Twice is the max. We'll solve the resulting equation. It's quadratic. Distribute to 4, which would give me 4x plus 60. That's 4 times 15. It's quadratic, so we'll set it equal to 0. Hopefully it's factorable. Bringing the 4x over would give me a negative 22x here. And bringing the 60 over would give me plus 21. And equals 0. And yes, that is factorable. It would be an x minus 21 times an x minus 1. So that says x is either 21 or x is 1. Now, anytime you solve a radical equation and you've had to raise powers, both sides, it's not a choice. You have to check the solutions. It is possible that one or both of them do not work. And what's happening is they solve the equation where you have gotten rid of the radicals, but they do not solve the equation, the form with the radicals. You can introduce extra solutions when raising powers. It's basically the long and short of it. So I've got to check both of them. If I put 21 in, 2 times 21 is 42, plus 7 is 49. Square root of 49 is 7. 21 plus 15 is 36. Square root of that is 6. And 7 minus 6 is not negative 1. So it's 1. There we go. That solution is no good. And if I put the 1 in, I'd have 2 times 1 plus 7 is 9. And this would be 16. Square root of 16 is 4. So then that would be 3. Ultimately, square root of 9 is 3. So 3 minus 4 is negative 1. So that one checks. So there would just be one solution, namely 1. Okay. Any questions on that one?
No.
Okay. So if you try to put, like if I had put 1 and 21 in there, hopefully it would say wrong. And it would remind you to make sure you check for extraneous solutions. So, all right. And then 18 and 19 fall out the same way. This is about the roughest kind of radical equation you can solve, just simply because it's got more steps to it. So to keep track of. All right. Any other questions from up through 23 radical equations?
No.
All good?
Yep.
Yeah.
Okay. Let's talk about the other types of equations in 1.4. I just want to grab a few examples. All right, so some of these equations are going to be able to be done without utilizing the technique of substitution. It's more about the technique of substitution that we're really wanting to cover here. So as an example, let's take this. Oops. X, for example, x to the 6th. So it's not quadratic. It's degree 6. Highest power will be 6 plus 7x cubed minus 8 equals 0. Now, in actuality, I could solve this just by factoring. It would be a quantity x cubed, looks like minus 8, times a quantity x cubed plus 1, and set that equal to 0. However, what I'm interested in here is this, utilizing what we call substitution. That is, we're going to change the variable and substitute in something else for it. But the goal is to actually write it as a quadratic, that is highest power of 2. And hence, this block of equations in the second half of 1.4 are called equations that are quadratic in form. That is, I can make a substitution and then write them as a quadratic, highest power of 2. And the process is going to be the same on all of these. Look at the middle term. You've got it in descending order. Look at the middle term and whatever its variable and power are. And I'm going to say, let's let U, kind of the international small case U, gets used for substitutions a lot. And I'm going to make that x cubed. So I'm simply saying whenever I see x cubed, I'm going to put in U to the first. Now, the second part of this is this. Once I make that, I'm going to say let U be whatever. I'm then going to square both sides. This will work so long as when I square both sides, you square U, you get U squared. You square x cubed, that is x cubed to the power of 2. Power rule says multiply the exponents. And 3 times 2 is 6. So U squared is x to the 6th. So this substitution works in terms of writing it as a quadratic, so long as when you square both sides of this, you get the leading terms variable in its power, which I do. So I can now make the substitution, and I'm going to have U squared plus 7U minus 8 equals 0. And then I just solve the quadratic. So it is factorable, so we'll solve it that way. I'll have U and 8 and 1. Need this to be positive, so we'll go plus 8 and minus 1. And so U is either negative 8 or U is 1. Now we're not finished because the original equation variable was x. And so I'm solving for x ultimately. So this always gets a little confusing for students at first. They want to do something with this. That was the second part in order for me to make the substitution. Go back to what U specifically is, and it is x cubed. So I put in x cubed for U, those cases. And at that point, I simply say, okay, how do I undo this? That is, how do I get x to the first? X equals whatever. So if it's x cubed, to undo x cubed, you would need to take the cube root of both sides. That is, I'm going to write it out. Cube root of x cubed equals cube root of negative 8. So cube root of x cubed is x. Cube root of negative 8 is negative 2. And then I would do the same thing here. And I'm not going to write it all out this time, but cube root of x cubed is x. Cube root of 1 is 1. And so at the end of the day, I have two solutions, negative 2 and 1. All right. Any questions on that technique of using a substitution to solve?
No.
All good? Have you seen this before?
No.
No, okay. All right, good. How many of you are looking at either taking calculus there at Roan or looking at a degree in the future that would require calculus as part of your program? I saw some hands up. All right. So when you take a calculus course, it really won't occur in Calc 1. But if you have to take Calc 2, when you're looking at techniques of integration, substitution is going to get used a good bit. So you definitely will see this technique again in calculus for sure. And rewriting integrands. All right, let's look at another one. Let's do this one. So I've got 3x to the negative second minus 7 x to the negative first minus 6 equals 0. All right. So definitely different powers this time. And again, it could be solved just by outright factoring without using substitution. But we want to use the substitution method as we want to write this as a quadratic. So I'm going to write, let's let u this time be x to the negative first. I'm going to middle term. And that would make u squared equal to x to the negative second. All right, so I can go ahead and make my substitution, which I'll now have 3u squared minus 7u minus 6 equals 0. All right, now we're kind of hopeful this is going to factor. Check the discriminant real quick. It's not necessary that it has to factor. And this one may be suspect. Let's see, 49 4 times 3 times 6. It is factorable. So let's see if we can get her factored. And I just plugged into b squared minus 4ac, came up with 121, which is a perfect square. So I know that it does have to factor. Now this would have to be 3u and u. 6 would not go here, though you could make it 2 and 3, which is, I believe, what we want to do. That would give me 9 on the outer, 2 on the inner, which I can combine 9 and 2 and get 7. Now we want to get our sign straight. So the middle is negative, so make the larger product negative. So I'll get negative 9u and then positive 2u, which would add up to be negative 7u. All right. So that would give me 3u plus 2 equals 0, or u minus 3 equals 0. So u here would be taking the 2 over is negative 2 and divide by 3. So negative 2/3. And here u would be 3. All right, so same deal. I've solved for u, but now I need to go back, figure out what x was. So u was x to the negative first. So I'm going to write x to the negative first equals negative 2/3. And x to the negative first equals 3. So I don't think I'm going to try. Here's my TI-84. I got to remember this, everything's backwards. And right on the left side, trying to make it the most visible, right below math, you see a key that actually says x to the negative first. And it's right beside the sign button. Now, if you would look up in the manual for the name of that key, it is called the reciprocal key. Back when you first learn exponent rules, you're kind of said, well, if I've got a negative exponent, let's say negative n, I can take it to the bottom and write as a what? Positive exponent, correct?
Yes. Yeah.
Okay. And if it's negative in the bottom, I can take it to the top. Take that base at the top and write as a positive exponent. But really, at the end of the day, what this and this is why it's so confusing for students. Negative signs. There are literally 3 different meanings, depending on where that negative sign is setting. It could be an operation of subtraction, like negative minus 6. It could be just saying a number is negative, or the opposite of a number. Like I could actually write this as addition plus a negative 6. But if the negative sign's in the exponent, it has nothing to do with the base being negative. It actually means reciprocate, or I want the reciprocal of that base to that power. Hence, when I look at this, x to the negative first equals 3, then that means x is the reciprocal of 3, which is simply 1/3. Just flip it. And same deal here. What's the reciprocal of negative 2/3? It is a negative 3/2. Now, if you really want to be real technical about this, you could, like here, I took what cube root of both sides. It's the same thing as raising both sides to the power of 1/3. I could raise both sides to the power of -1. That would give me -1 times -1 is 1. And then -2/3 to the negative power of -1, again, just means reciprocate. So, all right. Any questions on that one?
No.
Good. All right. Forging ahead. All right, so probably time for one more here. We got 3x to the power of 4/3 plus 5 times x to the power of 2/3 minus 2 equals 0. All right, we're gonna play the same game. Let's let u be x to the 2/3. Then if I square both sides, I got u squared. 2/3 to the power of 2, you multiply 2/3 times 2, and you get x to the 4/3. So I can, excuse me, make the substitution. I'll have 3u squared plus 5u minus 2 equals 0. All right, so let's see. I think this is factorable. Now it would definitely have to be 2 and 1. So it have to be 3 and 1 here. If I go with a 2 here and a 1 here, that's 6. So make that positive and make that negative. All right, so and that means that u is setting this one equal to 0. Take the 1 over and divide by 3. You're going to have u equals 1/3. Here, I'm going to have u to be -2. All right, so I got to go back, figure out what x was. So I'll go x to the 2/3 equals 1/3. And x to the 1/3 equals -2. All right, so when I look at this power, there's actually 2 things I've got to do here to undo it. That is to get to x to the first. If any number in the bottom is actually a root, that is cube root. Number in the top is just straight raising to the power of 2. So I have to do 2 things. I'm going to have to take the square root of both sides. And then I'm going to have to cube both sides. Or another way to think of it is, I'm going to go over here, right? I've got to or raise of power, that is when I multiply the reciprocals. So go 3/2. And what I do to one side, I need to do to the other. All right. All right, so here, 3/2 times 2/3 is 1. So that easy enough, x to the first. But here, I'm going to do this in 2 steps. I'm going to first cube both, and that's going to give me 1/27. And now still to the power of 1/2. Square root. All right. And more importantly, at this point, when I take the square root, I can't forget that is going to be, I got to take into account, it could be what positively valued or what negatively valued. And that's just coming from this rule here. If you have x to the power of n, and n is even, equals a, and x equals plus or minus the nth root of a, if assuming n is even. If n is odd, there's no plus or minus, but I do have to take square roots. Are you guys okay that x to the 1/2 incidentally, is the square root of x. Have you seen that before?
Yeah.
Okay. In fact, x to the power of 1 over n is the nth root of x. But if you have to take even roots both sides, you've got to do there could be a positive and a negative case. Okay, so now we've got all kinds of issues here because technically, though I personally don't have a real problem with this, you can't have a radical in the bottom to be according to Hoyle in most simplified form, and you can't have a radical which has perfect square factors in it. So we actually got two things going on here. So the first thing I'm going to do is just rationalize both sides here to simplify this, which would mean just multiply top and bottom by square root of 27. That gets rid of the radical in the bottom, still plus or minus. So we just have 27. Now in the top, square root of 27 times 1 is square root of 27. But 27 is 9 times 3, and the square root of 9 is 3. So this turns into plus or minus 3 times the square root of 3 over 27, and then the 3 goes into 27 3 times, or excuse me, 9 times. So ultimately I have plus or minus square root of 3 over 9. All right. So there's that. Now, for some reason, I did not write the 2 there. On this one, I'm not going to waste my time with it, simply because the instructions are going to say, when you do the homework on these, if this occurs, find the real solutions. And since I know that I'm going to have to take square root of both sides, if I take the square root of a negative number, that's going to give me a I. I'm going to have to extract out a root of I. That is, I'm getting complex solutions. So this one has no real solutions. So I'm not going to have to worry about it. All right. Any questions on that one?
No.
All good? Okay. So I think I've given you enough to go on. So where we're looking at here. Okay. So today is the 1st, which is actually, and it's just when I made the assignment on Monday, I just picked the 1st because that was I knew that that's when we were going to meet next. You can always work past due dates. And let me go ahead. Okay, so what I want you to do between now and Thursday, for sure, and I'm going to change these due dates here in a bit. I've got, as soon as I finish with you guys, I've got to jet up to Marietta, Ohio. So, and I've got a certain time I got to be up there. I won't get to change the due dates here for an hour or so, but I will get in there and redo the due date for the assignments here to reflect what I'm about to say. Finish 1.4, work through the problems of 1.4. If you have time, go on to 1.5, okay, which is inequalities. And then we're going to pick up there on 1.5, go over the inequality stuff. I don't think you're going to need a lot. I think it's going to be mostly review, and then get to 1.6, dealing with some absolute value stuff. And we will be looking at probably your first exam on chapter 1 coming up next week.
Okay.
So my understanding is you will take that with Ms. Deweese.
Yes.
Yeah.
Okay. So I will coordinate with her before next week on, because what I'll do is password protected. She'll punch in a password for you or give you the password. I don't know exactly how that's gonna happen, but we'll figure it out. Or I'll figure it out before next week. So probably, I'm just not sure. I'll just say next week right now.
All right.
All right, gang. That is it for today. Also, just in case this happens, I will